this topic map is, has a lot of stuff on it. It's basically kind of everything that I cover in my various climate change classes. So in this class, we won't hit all of these topics, but I think it's useful to just kind of anchor ourselves to this map and then dive into like whatever topic we're talking about that day. So it's like a syllabus, but just in 2 dimensions. I happen to be a kind of visual person, and so I like kind of mapping things out in schematic diagrams. For this first time that you're seeing it though, I will kind of briefly go over everything on it before we dive into what we're talking about today. So kind of like, where do we start in terms of the topics of this class? I think a natural place to start is with our fossil fuels. So our 3 main fossil fuels are coal, oil, and natural gas, and they are essentially powering our global economy. And so one way to think about our global economy is with these 4 terms, and this is something I'll talk about next time. We can think about the global economy as basically the number of people on the planet times the amount of goods and services consumed per person times the amount of energy that is required to produce a given unit of goods and services times the amount of CO2 or greenhouse gases that are emitted per unit of energy. So if any of these things go up, if global population goes up, if consumption and production of goods and services goes up, if the amount of energy that it takes to produce a given amount of goods and services goes up, or if the CO2 that it requires to produce a given amount of energy goes up, then that will mean that greenhouse gas emissions will go up. And conversely, if any of those things go down, then greenhouse gas emissions go down. So this is just showing that the coal, oil, and natural gas, our fossil fuels, support global economic production. But then they also have this byproduct that they emit these gases into the atmosphere, so these greenhouse gases. And the one that I'll talk about the most is CO2. And then there's other ways in which humans are emitting greenhouse gases. So one of the main ones is through our food production system. So we emit another gas called nitrous oxide that largely comes from fertilizer in our agricultural systems. And then CH4 methane largely comes from rice cultivation, as well as from the digestive systems of cattle, mostly burps and not farts, even though farts get most of the attention. And so these gases accumulate in the atmosphere, and then they interact with the Earth's energy budget and cause global temperature to change. And so then that global temperature changing has downstream consequences on various weather events. So that's kind of, we don't care so much about global temperature. We care much more about local impacts in terms of like climate extremes. So fires in California would be a good example. What's useful about this diagram is that you can kind of trace the chain of causality, where the amount of people on the planet affects how much fossil fuels are used, because that's supporting that, and then that affects how much CO2 is in the atmosphere, which affects global temperature, which then affects fires. And so it's through global temperature that the impact is being felt from fires. So it's not like CO2 directly is impacting the fires that much, although you could think of ways that that's happening. It's more through this pathway of temperature. We'll talk about tipping points, which kind of sit outside of this traditional framework, and those are just the idea that you can kind of push something for a while and not see very much of a response, and then all of a sudden see a large response. And so tipping points are something that people worry about in the climate system. And then downstream from weather and climate impacts are impacts on the environment and impacts on people. So I focus more on impacts on people, but a lot of scientists focus more on impacts on natural systems, ecosystems, and biodiversity. Certain ecosystems are extremely sensitive to temperature. Ecosystems in the tropical rainforests are examples, and warm water corals are examples of that. But then obviously there's impacts on people. So agriculture would be a good example. A lot of our crops really don't like very hot temperatures, and the more days that they spend above certain high temperatures really decreases their yields. And then all sorts of things in our socioeconomy. So if you increase fires in California, that's going to affect insurance rates and all sorts of things like that. And these impacts inspire governments to try to pass policies that either through mandates or regulation or other incentives try to move our energy system away from fossil fuel burning, away from coal, oil, and natural gas, and towards what we might call carbon-free energy or renewable energy. So the ones that get kind of the most play right now are solar and wind. And so these are sources of energy that don't emit CO2 as a byproduct. They're certainly not environmentally benign sources of energy, right? So very land use intensive. They're still materially intensive. Nuclear is another one on here that doesn't emit carbon, doesn't emit CO2, is a byproduct, but has other potentially negative environmental consequences. So there's no such thing as a form of energy that doesn't have, you know, environmental consequences of some kind. So it's kind of just looking at those trade-offs.